So for this first problem, we have three different kinds of t. So we need to set up a system of equations where there are three equations with three unknown variables. So if we let x be the t worth $4.60, y be the t worth $5.75, and let z be the t worth $6.50. Now we have our variables assigned. We can go through the problem and find how to set up our equations. So right here it says three kinds of t add up to be 20 pounds of t. So all three of our t's, x plus y plus z, comes together to be 20 pounds of tea. Then we're told that each tea has a price. So we have 460, 575, 650. And we see here that this 20 pounds of tea comes together to be worth $5.25 per pound. So the way we set that up, put 4.6 in front of x, put 5.75 in front of y, put 6.5 in front of z, and then our 20 pounds is worth $5.25 per pound. And 20 times $5.25 is 105. So we have two equations built so far. We need a third one. So right here it says the amount of the 460t. So the amount 460tx is equal to the amount of the other two kinds together. So x, the 460t, is equal to the amount of the other two t's, y and z, put together. So we have three equations, x plus y plus z equals 20, and x equals y plus z, and this one in orange here is our third one. So in order to use matrices, all of our variables have to be lined up. So the first two equations, x plus y plus z equals 20. And the next one, 4.6x plus 5.75y plus 6.5z equals 105. Those two are already set up. We just need to take this last one and solve it so that it's lined up just like the other one. So if I need x, y, and z all on the same side, I'll take y and z and subtract both of them from both sides. So what does that give us? That gives us x minus y minus z. And if I subtracted everything away from the right, that's going to be equal to 0. So x minus y minus z equals 0. So we need to set up our matrices, the coefficients from all of these equations. And now that we have everything lined up, we're ready to write our matrices. So x is first. We have 1, 4.6, and 1 as our coefficients for x. For y, our coefficients are 1, 5.75, negative 1. For z, our coefficients are 1, 6.5, negative 1. We put this bar to signify the equal sign, and on the other side of the equal sign we have 20, 105, and 0. So this is our matrix. And what we want to do now is we want to solve this matrix using the Gauss-Jordan method, or the Jordan-Gauss method, whichever one it was. So I'm going to move this down here. And I want us to see what we're going to try to get this to look like. So in order to solve this using the Jordan-Gauss method, what you want is you want to transform what we have as our matrix C so that you have ones all along the main diagonal, and this other side is just going to be whatever numbers fall out after we get ones along the main diagonal. So this is what it looks like now, and this is what we want it to look like. So because we want a 1 here and a 1 here, let's take a look at what we've started out with here. What we want to do is we want to rearrange what we have in order for it to match what we want. So if I want a positive 1 here and a positive 1 here, right now I have a positive 1 here and a negative 1 here. However, if we switch row 1 and row 2, if we switch their positions, then I'll have a positive 1 here and a positive 1 here. So that will be the first operation that we perform on our matrix. I want to switch row 1 with row 2. So my new matrix is going to be 1, negative 1, negative 1, 0. We're not switching row 1 and row 2. We're switching row 1 with row 3. Row 2 is going to stay the same. And row 1 is moving down to row 3, so 1, 1, 1, 20. Now again, the reason why that we perform this step first is because now I have a positive 1 in 2 of the places that I needed a positive 1 for. So now I'm looking at what I have, and I'm trying to decide what I need to do in order to get zeros here and here. So I look right here at row 3, and I notice that if I add row 1 to row 3, I'll have zeros here and here like I want. So that's one of the steps that we'll do next. We'll say row 1 plus row 3 is going to be our new row 1. So at the same time you're working on that, you can also start to work on making this value right here 0 also. So how would we do that? We would need to add row 2 and row 3 together, only we would need to multiply row 3 times negative 4.6. And that's going to give us our new row 2. Okay, so let's work on that. We have row 1 plus row 3. So 1 plus 1 is 2. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. And 0 plus 20 is 20. So that completes this command right here. We have added row 1 and row 2 together, or row 3 together to get a new row 1. And we have zeros in 2 places that we didn't have zeros before, which is good. So the next command that we gave was row 2 plus negative 4.6 times row 3. So if I take row 3 times negative 4.6, 1 times negative 4.6 is 4.6. Add that to 4.6, gives you a 0, which is what you wanted in this spot. Now, the rest of the numbers are just going to fall out however they fall out. So negative 4.6 times 1 is still negative 4.6, but when we add that to 5.75, we get 1.15. Negative 4.6 times this one gives you another negative 4.6. When we add that to 6.5, we get 1.9. Negative 4.6 times 20. Negative 4.6 times 20 plus 105 is 13. Okay, and we didn't change row 3, so we're just going to leave row 3 as it was.